Multiplying monomials and polynomials. As you can see by this example here, we have base of 10 and then we have exponents 2 and 4. And all we've done really to get from when we multiply is to add the two numbers together. So 2 plus 4 is 6. And we have our evidence down here. 100 times 10,000 will give us 1 million. And again, it's just a combination of the zeros. 2 zeros here, 4 zeros there, gives us 6 zeros over here. This is all related to product of powers. And that's simply stating that you can multiply powers that have the same base by adding their exponents. So algebraically, this is what it looks like. We have the same base a here. M is our exponent, n is our exponent here. So when you multiply these two powers, you get a to the power of m plus n. Looking at some examples, 6 to the third power times 6 to the fourth power. We would first combine our exponents here, same base, and then add them together and we get 6 to the seventh power. So we could actually take 6 to the third, multiply it by 6 to the fourth, and that would be the product of 6 to the seventh, whatever that would be. Here's an example with some variables involved. The variable of a, which will be our base. We combine the base together, which is simply a, and then we're adding our exponents. And the solution would be a to the seventh power. Now let's look at something a little bit more complicated. Here we have y times the parenthetical statement of y minus 5. And we can solve this in one of two ways. The first way, we're actually going to use our algebra tiles. So here we have y squared, and then negative y, negative y, negative y. As you can see, we have 5 of those there. This side represents y. So this would represent our base here. And this side represents our parenthetical expression up here. But before we show the solution, let's go ahead and see another way of solving this, and that would be using the distributive property. We have the same problem set up, and what we've done is take y, and we're multiplying those together, so that's represented in this set of parentheses. And then we have our subtraction sign down here, just move down. And then for our second parenthetical expression, we have y times 5. Now don't think that you put the subtraction sign there, it's always multiplication. And I'll show another way to do that in just a moment. So now we're just going to simplify these expressions. And our answer is going to be y squared minus 5y. And that's what's represented up here. Y squared minus 5y. We have 5 negative y's, so negative 5y. So that's the distributive property in use. Let's take a look at one more example. Now for this one, you'll notice that our base is being cubed, and we also have it to the power of 4. And our tiles only go up to x squared and x, so we really don't have a tile for this. So we're going to have to use the distributive property to solve this expression. So I went ahead and put x cubed there, x to the fourth there, we're multiplying. Addition sign in between because we have addition as our function there. X to the cubed and then 5 there. And now we simplify. X cubed times x to the fourth gets us x to the seventh power plus, just moving it down, 5 times x cubed is 5x cubed. Now, when I learned the distributive property, this is not really how I used it. I used it, or learned it in a slightly different way. So looking at the same problem, instead of doing these parentheses up here, I'm just going to go ahead and say, okay, x cubed times x to the 4th gets me x to the 7th. It's still addition, so I'm just moving that down. And then I ask myself, 5 times x cubed, what does that give me? And that's going to be 5x cubed. So here's our solution. So either way that you're comfortable with is fine. Sometimes the algebra tiles will work if you're working with x's or x squares, but anything beyond that, at least for our purposes here, it's probably going to be not really that helpful. So I would stick with the distributive property either with this setup or with this setup.